Okay, so it's a factor of the constant term divided by a factor of the leading coefficient. When I'm looking at a function, how can I describe the constant term?
By the degree.
Not really the degree.
Number that.
The number without a variable. So I'm even going to put a little reminder of that to myself. So the constant is the number without the variable. You may or may not need that. So the constant is the number without the variable. What's the leading coefficient?
The number with the highest exponent.
So the number, the first number, whatever the first term is, with the leading exponent. So I'm just going to put the first number, assuming it's in standard form. And we're going to talk about that as we continue through. So I don't want you to write down this first one because we're going to have enough examples, but I just want to kind of talk through some stuff. So don't write this down, but let's say we have f of x is 4x squared plus 3x plus 5. So as I'm looking at that, what's the constant?
5.
So here's my constant. And then I'm going to look and I want the leading coefficient. Someone besides Robert, 4. He always beats us to it. So this is the leading coefficient. So if I look at this, but it's not just the leading coefficient, it's not just the constant over the leading coefficient, it's a factor of those. So then I go back and I say, okay, I need factors of these. Well, a factor of 5 could either be 5 or 1. Factors of 4, I could have 4. I could have 1. Could I have any other factors?
2.
I could have 2. 2 and 2, but I'm just going to put it once. Well, let's see. So a factor of the constant, so maybe it's 5, divided by a factor of the leading coefficient. Maybe I pick 4. A factor of the constant, maybe I picked 1 this time, divided by a factor of the leading coefficient. Maybe this time I pick 2. Maybe this time I decide to make it negative. Maybe the next time I say, okay, this time I'm going to pick 1 again, but this time over here I'm going to pick 1. And I'm going to decide to make it negative again. Can I pick another combination? I think so. Reagan, give me a different combination. 5 over 2. You want it positive or negative? It's going to stay positive this time. Robert, give me another combination.
You do a positive 1 over 2.
1 over 2, but this time he's going to stay positive. I bet there's a few more. We're going to have to list all these combinations. When I list all these combinations, gosh, it would be really helpful if I was organized about it instead of just being really random like I was here. So as we make these lists of factors, we're going to be organized in how we do it so we don't miss any and we don't repeat any. So that's why I didn't have you do this one because I was just all over the place. So let's write down this, and let's also put directions here. Let's say list, and let's put this word possible, zeros. So you don't need to write all that, but let's put list possible zeros, and then go ahead and write down that function. F of x is x to the third plus 2x squared minus 11x plus 12. And so I'm going to write my P and my Q. So the P is the constant. So Jared, what's the constant? 12. So this first one, I'm even going to circle it. I'm going to put the P right next to it. I won't do that, everyone, but I'm going to go down here. I'm going to put P. You can put equals. You can put a colon like I did. But I'm going to put P is 12. But then I need to list the factors of 12. Personally, I like to list them in pairs. That's how I remember my factors. If you want to do it numerically in order, that's fine too. That's how the book will do it. But I just say, okay, I know 1 and 12 is a pair of factors. What's another pair?
2 and 6.
I heard both of them, 2 and 6, and I heard 3 and 4. It doesn't matter if yours are in a different order than mine. So then I'm going to go to the leading coefficient. Michaela, what's the leading coefficient?
1.
Yeah, even when it's not in there, we know it's 1. So again, I'm going to circle it. I'm going to put that as Q, the leading coefficient. So we go to the last number first, the first number second. Q is 1. Well, 1 only has one factor, 1. We only list it once. And then we're going to make our list. We're going to take each one of these factors, whatever order I listed them in, it doesn't matter. And we're going to divide it by each one of the Q factors. Well, good news is that I only have 1 this time. Sometimes we'll have 2, sometimes we'll have 3. I usually won't give you more than 3, maybe 4 at the max. And so I'm going to take each one of these and divide by 1, but I'm also going to put plus or minus in front of each of them. So I'm going to say my list is plus or minus 1 divided by 1. Well, let's also reduce, so let's put 1. 12 divided by 1, so it's 12. Well, I'm dividing by 1. It's really just this list. So plus or minus 2, plus or minus 6, plus or minus 3, plus or minus 4. Those are all the possible zeros to this function. And we'll come back to that idea in just a minute, but I want to get the idea of how to make this list first. Do you think I care if your list is in a different order? No. The book will have it in a different order. The book will go plus or minus 1, plus or minus 2, plus or minus 3, they'll go numerically. I don't care what order yours is in. Now, before you write this down, one thing I might do or the book might do as we get a little bit farther is they might try and throw something out of order. So check before you write it down, make sure it's in standard form. Is this in standard form? Okay, so I didn't try and trick you, so go ahead and write it down. So f of x is 4x to the 4th minus x cubed minus 3x squared plus 9x minus 10. Savannah, what's the p, the constant? Yeah, and usually we pull out the sign with it, but since I have that plus or minus, I actually don't need it. So this is one time we could just put 10. And if you put negative 10, that would be okay too. Kyle French, how about the leading coefficient?
1 and 2.
Those are my factors.
Oh.
The leading coefficient of this whole thing. So the Q.
Oh, before.
Yeah, so the Q is 4. And then I'm going to go and I'm going to do my factors. You could do it in the opposite order. That would be fine. So factors of 10, I'm going to put 1 and 10. I usually start with that pair. And then he's right, 5 and 2. For 4, usually start with 1 and 4. And then for 2, I only write that 2 once. I only need it once in that list. So this list is going to be a little bit more involved. I'm going to take each of the p-values and divide by 1. So it's really just each of those with plus or minus in front. So plus or minus 1. Make sure you are separating these with a comma so they don't all run together. Plus or minus 10. Plus or minus 5. Plus or minus 2. Now, since I do have division by a second number, when I go through, I want to make sure I don't repeat anything. I want to make sure I'm reducing too. So I'm going to do 1 divided by 4, 1/4. Well, it's not in the list. I didn't have any fractions. So plus or minus 1/4. 10 divided by 4. Well, I can reduce that. 5/2. So plus or minus 5/2. If you're using your calculator and you write 2 and 1/2, that's fine. 5 divided by 4. That doesn't reduce. It's not in my list. Plus or minus in front. 2 divided by 4. That's 1/2. Not a fraction that's in my list yet. Plus or minus 1/2. I've gone through all those divided by 4. Now I got to go through and I got to divide all these by 2. When you get to the third one, that's when you really got to start to check to make sure you don't have repeats. 1 divided by 2, 1/2. Is it in our list?
Mm-hmm.
Yep. Okay, move on. 10 divided by 2, 5.
Yep.
Oh, in our list. 5 over 2 doesn't reduce.
Yep.
In our list. 2 divided by 2, 1.
Yep.
In our list. We actually didn't have to add anything. So there's my list. So always reduce. Don't put any repeats in our list. We can add that. Always reduce. No repeats. Okay. So now we're going to use this to help us solve. Well, it was a little bit of a struggle this morning. We'll see how much of a struggle it is for us. We're going to find the rational zeros for this. So we've got f of x is x to the third plus 9x squared plus 23x plus 15. I want us to think about that quiz we just took yesterday. I know some of us don't want to think about it, but we're going to think about it. Think about the front. If I asked you to solve something like that on the front and it had 4 terms, you are probably going to be able to solve it by grouping. I got bad news. This doesn't group. Okay, so that's out the window. So then you flip the quiz over and it was on the back. What did you do on the back? Synthetic. So if this was on the back, what other information did I give you?
A binomial or an x equals.
I gave you a binomial or an x equals. So if I was asking you to solve, I would have said, hey, and don't write this down because I'm just making this up. I would have said, hey, x equals 3. And the reason I would have done that is because you needed a starting spot because this doesn't group. And so you needed an x equals so you could say, okay, I know one answer. I can divide that out. I'll do my synthetic. I'll be able to factor what's left. And then I can get all my answers. I have nothing. What should I do? You're not allowed to use photo math. What could I try? There's no GCF. What could be a solution? Anything, right? Any number in the world could be a solution to that. 1 might be. 500 might be. -7 might be. I could try any number in the world. How would I know that a number was a solution? We know. What? Not necessarily if it's a factor. When I gave you this, how did you know that it worked?
You got a remainder of 0.
Because because you got a remainder of 0. It was a solution because you got a remainder of 0. That was that other theorem we talked about. So I'm just going to start trying numbers and hope I look into something where I get a remainder of 0. Really? How many numbers do I have to try? A lot. Well, that's where this list comes into play. That's what this theorem is saying. This theorem is saying instead of trying the infinite set of numbers, because that's what rational numbers are, it's infinite, is I can use this theorem and I can make it much smaller. So let's do the list for this problem. So let's do our P and our Q. So Colby, what's the P of this problem? Okay. And Q is just 1. I'll go ahead and do that. So factors of 15, we've got 1 and 15, 3 and 5. Q, we just have 1. And as we progress next week, we won't always have to do the list as well, because the list is going to start to be pretty repetitive, as you see here. We're just going to do, all these divided by 1. It's just all these with plus or minus in front. Plus or minus 1, plus or minus 15, plus or minus 3, plus or minus 5. So I've just been able to take an infinite set of numbers, and instead of it being all the numbers, it's, let's see, positive 1, negative 1, positive 15, negative 15. So it's 2, 4, 6, 8. There's only 8 numbers that are possible solutions. Now, good news, bad news, I said. It means these numbers are only possible solutions. Doesn't mean these numbers are, but it means if it's not one of these numbers, it's definitely not. So if I tried to tell you x equals 7 is a solution, don't believe me, it's not. But I had up here x equals 3, I may be telling the truth. I may not be, but I may be, because it's part of the list. But if it's not in that list, there's no way it's a solution. So we tried numbers in that list to see if it works. That's still 8 numbers. That's still a lot of solutions. So I'm still going to make it easier on you. When we try, we're still going to try. I'm still not going to give you the answer, but we're going to start with the smallest number first. So what's the smallest number? 1. So we're going to try 1, and to see if it works, we're going to try synthetic, and we need the remainder to be 0. I told you we're going to use synthetic a lot. So we're going to put x equals 1, just so we know what we're doing. Standard form, nothing missing. 1, 9, 23, 15. And for the problems I give you, this isn't the case in real life, but for the problems I give you, if you try 4 things, if you go in order from smallest to biggest, you're going to find it. So if I try 1, negative 1, 3, negative 3, if I haven't found a 0, I did something wrong. So let's try 1. 1, 1, 10, 10, 44. I can already tell this is going to be too big. I'm not going to get it to cancel out. So I'm going to cancel that out just by crossing that out. I'm not going to erase it, because that way I know that I tried something. If you want to erase it, you can. So 1 and then the negative 1. That's the order I want you to go in. So let's try it. Same numbers up top. You're going to get really good at synthetic, hopefully, if you're not already. The downside of that is sometimes you're going to go too fast. You're going to make a careless mistake. You're going to add when you should multiply, multiply when you should add. Careful of your signs too. Negative 1, 8, negative 8, 15, negative 15. There's our remainder of 0. So that means that x equals negative 1 is a solution. And that means I bet I'm going to be able to solve with whatever's left. Just like what we were practicing in the last couple days, we can't lose track of this. This is all building on top of each other. So that means there's a binomial that goes with this. The binomial that goes with that is x plus 1. See how this is all coming together? This is a trinomial that goes with that. It's x squared plus 8x plus 15. I'm going to write it up here higher so we can see better. So I'm down to x plus 1, x squared plus 8x plus 15. What do you think I'm going to be able to do here? Factor. Guess what? Next week we may not always be able to factor. We might have to, guess and check is factoring. Quadratic formula. I'm just hitting you with all kinds of stuff. But we'll say that for next week. So that does factor pretty nicely. So we get x equals negative 1, negative 3, negative 5. Are those numbers in my list?
Yes.
Yeah. If I got to that step and those numbers weren't in my list, I did something wrong. But all those numbers are in my list. All right, let's try some more.
Is it gonna be easy when we do this eventually?
What?
Is it gonna be like an easy way to do this eventually?
No, this is it.
Oh, are you serious?
Why is this hard?
Cause it's like a lot, I guess it's like typically there's like a solid thing.
There's just too many.
This is easy. This is just. This is not hard. This is, you have to persevere. I'm asking you to check 4 things. You go over to pre-calculus, you have to do it 10, 12 times.
This isn't why I'm taking.
This is not hard. This is just persevere a little bit. Show a little grit.
It's not hard. It just takes a little while.
You're lazy. You're lazy. Show a little grit. Here we go. Moving on. Don't be lazy. You've got f of x is x to the third minus 8x squared plus 11x plus 20. Again, today, because we're getting the practice with it, we're going to do PQ and list. Next week, we won't always have to do the list. What's the P?
20.
Good. Q?
1.
Oh, I accidentally put that in. I'm glad.
And even if it had been negative, remember, you can put the negative there. We really don't have to because we have plus or minus in our list. So 20, we're going to list our factors. 1 and 20, 2 and 10, 4 and 5. Q, we've just got that 1. So plus or minus 1, plus or minus 20, plus or minus 2, plus or minus 10, plus or minus 4, plus or minus 5. I could make this really hard for you guys. I could say, hey, have at it. But I make it even easier on you. I say you start at the beginning, start with 1, -1, then go the next 2 smallest, and you're going to find it in the first 4. And yet you still want to complain.
No, I'm thankful.
Thank you, Kyle.
Wow.
I'm going to have someone's back. What should I start with?
1.
1. Let's see if it's going to work. 1, -8, 11, 20, -7, -7, 4. Darn it. You will get 1 to work sometimes. Don't think it doesn't. So always try the positive and the negative value. Roman, you just let me try it? I would appreciate you to try it too. I think this is going to work, folks. Remainder of 0. And we'll put in our notes here after we finish this problem that solutions mean the remainder is 0. I know we have that before, but we'll just put that reminder in. Yes, ma'am. Oh, yeah. Posting it too.
Because Emma's been watching.
Oh, yeah. All right, so remember, and this is what will happen. I've been trying to help you get in good habits, but remember, don't lose track of this. And so we're going to have x plus 1. And then, okay, that means we're going to have x squared minus 9x plus 20. Put it up here again so we can see better. Got a pretty nice, easy one to factor. Today you're going to have those basic binomials, no guess and check today. Oops, I didn't start factoring. Signs the same in both negative. 4 and 5, 5 and 4. So you get -1, 4, and 5. That didn't seem so bad.
Not yet.
It won't get bad today.
Oh, yeah. does that quadratic formula.
Quadratic formula? That should be just plug and chug.
It is, but it's just like,
Wine. Oh, let's put down, I said we were going to put this down. So, solution, I can spell, solution happens when the remainder is 0. I think I have 2 more, but let's see. Oh, I have 3 more. Let's see. We won't have to do all 3. Let's do this one. F of x is x cubed plus 2x squared minus 29x plus 42. P is 42. Q is
1.
1. Oh, we got tons of factors here. Let's see. We've got 1 and 42, obviously. 2 and 21. I think 3 goes in there. Thanks. 4 doesn't. 6 and 7. I think that's it. So, plus or minus 1, plus or minus 42, plus or minus 2, plus or minus 21. Again, Monday we'll have a shortcut for this part. Plus or minus 14, plus or minus 6, plus or minus 7. What should I start with?
1.
All right, here I go. I don't think it's going to work. Now, sometimes what will happen if you make a mistake in your synthetic and you miss a 0, you could always find a 0 later on. So, like on this last one, if I had missed -1 and I'd been persistent and I'd kept going, and even though, let's say, I tried to -2, it wouldn't have worked. And I said, well, I know I was supposed to find it, but let's say I just kept going. If I had tried 4 next, I would have found it. And I could have kept going. Okay, let's try -1. Oh, is this not going to work either? Darn it. What should I try next?
2.
2. Dylan set his pencil down. Is 2 going to work, Dylan? Okay, he's giving us the green light. It's always nice to have someone working ahead. 1, 2, 4, -8. No, +8, sorry. -21. -42. He is right. So again, we don't want to lose that. That is going to be a common mistake, especially I hate to say this after the hostility I'm getting today, but they are going to get longer some next week. And so losing terms is going to be a common mistake. If it's x equals 2, we're going to put x minus 2, and then x squared plus 4x minus 21. So that factors pretty nicely. +7, -3, 2, -7, 3. If I would have tried any of those numbers with my synthetic, That would have gotten me a remainder of 0. We'll knock one more out, and then I'll give you the homework assignment. I'll tell you, this one will take a little shortcut. I won't make us do a list. We'll just do P and Q. We'll kind of give you a sneak peek at the shortcut. So f of x is x cubed minus 5x squared plus 7x minus 35. So even when we get to this shortcut, you will still list the P and the Q. What's the P? 35 or negative 35, either one would be fine. You will still need the factors. 1, 35, 7, and 5. Oops. And you will still need the Q. Q is still 1. But even if the Q was, say, 2, if you divide all these by 2, you're going to get what? What? Yes. Expand on that. So, like, what are these? Fractions. Are you going to want to do synthetic with fractions? No. So you're really only going to do your synthetic with these numbers, the plus and minus. So the shortcut is going to be, you're going to use these numbers, positive and negative. We'll talk about that more next week. But I'm saving us a little time here. Don't look super confused, Roman. You're not doing this tonight. All right. So we're going to do our synthetic. We're going to do 1. All right. 1, negative 5, 7, negative 35. So let me put my x equals with it. Just once, I'd like to be lucky and get it the first time. I think the one I skipped was the one you get it the first time. You do have some on your homework where you get it on 1. You can try negative 1. One and negative 1 doesn't work. What's my next factor? 5. Oh, this is a little weird. 0. Oh. Worked. This part's a little weird, so it's good we did this one. So this part, we're going to have x minus 5. Here's how I think maybe a good idea to write this part. Let's write this part as x squared. This would be 0x. Why don't I just skip over it, and why don't I just put minus 7? Maybe if it's helpful, because this is really just x squared plus 0x minus 7. Oh, so when I skip over that 0x, that's a little bit easier to see. How can I solve that x squared minus 7 part? Let's do the square root method. So we're going to have x equals 5, and then here we're going to have x squared equals 7, square root, x equals plus or minus square root of 7. Oops, I forgot the 3. There is your homework. On 4 through 6, you are just doing the list. I say this every year. There's always people every year that don't listen. 4 through 6, PQ list, stop. Do not do synthetic because it will not happen in the first 4. PQ list and stop on 4 through 6. 11 through 13, those are the ones you're going to solve. Have those ready for Monday. And then Monday, just to kind of give you a heads up, I think what we're going to do is we'll obviously do more of the same stuff, but that assignment I'm kind of planning on doing that. We'll get an assignment. We'll also kind of work on that assignment Wednesday as well, and that assignment will be due on Thursday. That way, you don't really have homework Monday or over the ACT day. Those of you that are juniors, those of you that are seniors or sophomores, you really kind of get a break. Lucky you. Really rub it into the juniors.